My name is Matthew Clance. I've finished my PhD at Clemson University in 2012, so I've been here since 2013. So my research typically is very broad, bouncing from international trade to different versions of development, whether it's childhood outcomes, some climate change outcomes, and then also applied econometrics. So just to give you a background, I sort of do a lot of different areas, but at the same time, um, some of that work might fall into some of the stuff you're doing, which we might be able to help out while we're going through these particular slides or adjustments to the slides. So keep that in mind. If you see something that might apply, we can expand upon what we're actually discussing if it might help what you're doing. Because there are a lot of people here doing PhDs. It's not, we stick to this and, we don't deviate. We should deviate, especially if, it can help in terms of, focusing or even, simplifying some of the work that you're doing. Okay. So, as I said, we're going to be doing the Google folder basically the way I'm going to share everything when it comes to data. Eventually, I will be putting some code in there, but I'm waiting on that just so that basically we can talk about it first before putting any type of R script in there. We're going to do basically a general introduction to this program, okay? And then we're going to have some general information about the RStudio, about these types of programs in general. We're going to focus on scripts and how you basically go about reading how the platform looks. We're going to look at some of the data reading as well as, manipulation as well as visual presentations. And then we're going to do an example of reproducible work. So just to get this sort of out there first. So the reason why we're pushing for R, where usually you've used Stata or something else in the past, is basically this is a program that basically encompasses everything that takes you from data to manipulation in the sense of getting in the right formats to actual producing PDFs or even websites. So everything that you do with your research can be basically handled by one program. Okay, so that's why even these slides that we produced here, I never left RStudio or R. Basically, everything was produced through here in combination with different programs. So we'll kind of discuss that as well. It's the reason why we're kind of shifting from using Stata to R. Okay, so from my side, I am self-taught in programming. Never took computer science, programming course or anything. What does that mean? Basically, my code is not always very organized. It's very haphazard in some cases. Okay? So the way I do things is not the only way, and it's probably not the most efficient way. So there's going to be a lot of different ways to do this. So as you go about, find the best method for you. And basically, I put this cartoon on this slide is basically somebody who understands programming and basically how they would look at your coding if you're not used to that. But if it gets the job done and it's done with the best accuracy possible, then it's still doing what it's supposed to be doing. Okay? So just keep that in mind, that you're basically, especially at the very beginning, you're going to start out maybe not doing things the most efficient way. But we're going to try to, as you work through it, basically you'll get better at it. Okay. So just a question before we start. So how many people have used command line statistical programs in the past? Okay. What programs were you using? Python? Okay. So, Stata? Okay. Okay. So eViews is sort of an in-between. It's kind of a it's becoming more command line, but also it's still what we refer to as a point and click system. So I'm not going to say it's not, but it basically, when you're thinking about going one step above certain programs for command line structures, we're thinking Python. Stata is close there, but it does have options for point and click as well. So the whole purpose of this is better research in some ways, more compact and organized research. So we're basically going to be using these for basically importing of data, getting the data in the right formats, as well as using graphical and table output. That all comes from this program. The reason why we're trying to do this is because a lot of times people jump between programs, and that can cause issues with consistency between two things that you were doing. And then so in terms of estimating a model, I take it you've used Python before for estimating a model. So a lot of times like this, we're estimating a model, but sometimes using the pre-programmed one leaves us sort of handcuffed in some ways. We need to be able to basically modify and adjust these programs to allow us to do a little bit more rigorous or make modifications to what we're doing to hopefully do a little bit better in terms of research. Now, I know that Excel is very useful software. It's, kind of falls within that point and click type system, eViews and SPSS, depending on who you speak to, but that does make them more user-friendly, which is good for starting out. But once you take over to the next step to try to go a little bit beyond, you have to basically use something a little bit that would help you be a little bit more rigorous in what you're doing. So the way I say it is basically that it's not always the best for frontier economic analysis. Now, student and researchers basically find a program they like. They stick to it, or the supervisor likes. Now, a lot of times, I'm not going to tell you that's bad, because even for eViews, if you're in the macro economic research in those areas, it is some of the best for that. I mean, it helps out a lot in terms of producing what you need to do. Okay, so if it's helpful for you in that area, then you should use it, but you should use it with something that's more in combination with other things. So basically, when it comes to this frontier analysis, basically it needs to be a little bit more rigorous. It needs to be a little bit more flexible to allow you to basically conduct the analysis, primarily because for a lot of things that we have that we're supposed to be doing, the papers that we're reading, that we're supposed to be trying to do research with, have not had programs or packages created for them yet. A lot of times we basically, if you're sitting there waiting for it to be packaged and then use it, usually you're already behind the curve. Okay, so that's where these types of programs will kind of help you with that. So one is basically not having to rely on off-the-shelf type programs, and then also thinking about reproducible, transparent research, which is being very big nowadays, given some of the things that have happened in terms of research, recalls of papers, and especially when it comes to AI. Okay, you need to be very open with what you're doing and not just say, you built this data set, here's my results, trust me. Okay, so that's where this sort of comes in. Then it also adds a little bit of versatility to what you're doing. Okay, so that's why we're using R. But I'll go ahead and tell you that I don't use just R by itself. I do use programs that allow for combinations of things. So they take a little more investment, and like I said, serious research usually requires you to be a little bit more rigorous, and basically reproducible research allows for being open and sort of transparent what you're doing. And then I ask basically, are there advantages to learning more than one statistical program? Yes and no. like I said, it takes investment, but when it comes to basically being as versatile as you want to be, is speeding up your types of things that you're going to be running, that's where it can actually be beneficial. Okay. So even though I'm showing this, I actually use several different programs depending on the purpose. Okay. So each additional statistical package adds a little bit of flexibility. In some of my work that has some things work faster in certain programs than others. So basically it can, for my work, it typically adds a lot of speed to some of the simulations and things that I'm doing. But like I said, there is a disadvantage to that. You know, some people don't like the additional complications that come along with that. So you have to do it from whatever you're working on. And then also in terms of methods, like I've already said, sometimes something that's coming out will take several years to actually have a package created for it. They're not always, as soon as the paper comes out, somebody shows and gives the program out to what you're doing. So sometimes it can take several years. And they're not always, you know, you find one program that works in Stata, but R hasn't produced yet. Or there's one in R that Stata hasn't produced yet. Or similar for Python and other things. That's why I'm saying it can be beneficial to you. And then also, there's a whole community for these user-written commands that basically, they just come out at different times depending on who's working on them. So basically just choose the best tool or that you need for that particular task or job at hand. It can improve productivity, but just be careful. Don't get too, don't beat your computer up after it, you know, it's having some issues. Yes?
Right, thanks. With R, any differences if you're using a MacBook or Windows?
There is a little bit of issues, or I shouldn't say issues. It's basically differences behind some of the programs, but most of them. I mean, I share work, or I work with someone that has a Mac and they use R. We don't really have too many difficulties working, but I have seen issues with certain things. So one thing that I do know Mac does very well is parallel processing. It's a lot easier. I call it one thing, I'm not sure if that's the name of it. It's MC Lappy. It works very well with Mac and basically streamlines parallel processing. That option is not available or not straightforward in Windows. So there are a few things, but I'm not knowledgeable enough to tell you which ones they are. Okay. And then basically I just say at the very end, the more you know, and especially when it comes to programs, the better your job prospects are for a lot of things. Okay. So for this course, we're going to use RStudio. Well, I should say R or RStudio. RStudio is just sort of an overlay on top of R that makes it a little bit more user-friendly. Okay. So, but you need R to run RStudio. You don't need RStudio to run R. Okay, so just, you should go ahead and kind of download both of those if you can. But basically, most of the things that we're going to show here, including the reproducible research, can be accomplished in Python and Stata. Okay, so it's not like this is your only choice for this. These programs are becoming a lot more versatile than they used to be. And I only use this because basically in RStudio, I can run Stata code, Python code, MATLAB code. It allows me to do that. That's one of the reasons I use it. So it just basically integrates very well with a lot of different programs. It's open source, and that's a good thing because a lot of people write programs that we wish were on the Crane website that are not yet. Okay. So we're going to start with a general overview of RStudio, data types, interface, things like that. We're going to basically go through and try to build a data set, analyze the data set. When I say write a paper and report and presentations, we're not going to sort of show that today. but I'm going to show you how to create an HTML file that produces from this program. It's a little bit simpler to use HTML just because it doesn't require an additional program to be like LaTeX to be downloaded, but it still does what we're going to show. Then we have a lot of different R resources here. So Crane is probably the standard. When it comes to, I should have put Posit here and not RStudio. There's also R for data science, which is basically an entire book that basically goes through all types of situations. Stack Overflow is a very good one for errors and things like that. And GitHub would most likely be primary for a lot of you when it comes to papers that are just being produced. Because we're trying, the field is trying to become more transparent, we're basically releasing code on these sites that allow us to basically sort of, get our citations, but at the same time, allow people to see and to critique that type of work that we're doing. Okay? So a lot of these will be sort of helpful and probably standard for what you're going to be going through in terms of getting a little bit better with these programs. So I say this prior groundwork, and like I said, at the break, we're going to sort of try to catch everyone up and probably a little bit into the class just to get everybody set up. But basically, if you can, we do need you to download R and RStudio. So basically, I said, if you haven't downloaded them yet, we'll deal with that a little bit later. But right now, focus on what we're going to be showing, and then we'll kind of go into that technical side when we can. These are optional extras here. Now, when it comes to actually producing slides like I did here, PDFs for your papers, HTML websites, all those things, you need an interface that allows you to do that. So LaTeX is one of those. Not everybody uses it this way, but that's one I use. We also use some shorthand type coding and a version of Markdown, which is using Python, you can use called R Markdown. And then Pandoc is mostly a translator. Basically, it helps you convert things from Word into PDF, PDFs into Word, PowerPoints, and so forth. Because I know that if you've made presentations and you've tried to do papers and you're trying to go back and forth between the two, it can be a headache. This is more of a translator that allows it to be a little bit quicker on what you're doing. Generally, if there's no errors, it's pretty quick in terms of a minute or so, in terms of a build, is what we call it. So these are the optional extras. Don't really worry about these for right now. It's probably more important to sort of focus on the top two for right now. So given sort of what we're going to be going through today and how we are actually kind of set this up, how many people have actually used R in the past? Okay, so about 5 of you. Just asking, how did you find it? Is it what you started on, or is it something you just tried out? So you tried it out, but so why'd you stop though? Just to ask. You started trying to use it, but did you? I guess you didn't continue using it.
I used it when I wrote one book, but when I stopped.
Basically, is it because it's difficult or just not within your field, or? Yeah, so that's where the investment time comes in. So yeah, that's what I'm trying to say. It's going to be frustrating in the beginning, I know, but so we're going to try to ease that in a little bit, hopefully. So R and RStudio. I kind of switch between the two, so sorry, but basically when I say R, I'm referring to RStudio. So basically we're going to just kind of go over some of the terminology real quick. So when I'm referring to libraries, I'm basically referring to packages. Those statistical programs within the packages or the base functions that we use within there basically are contained within these libraries. We can basically install each one. They do not come pre-packaged on your computer. If you're used to using Stata, then basically it's like using SSC install. That allows you to update the system to these new user-written programs. Once we have it, even though we installed it, the computer or the program does not know to use it yet. So basically we have to tell it that we need to use it. So this is one of the structures that kind of gets to people that basically when Stata, I put it in my computer, it knows what commands are there. And basically it'll start using it as long as I ask for it. In R, these packages are not loaded at the very beginning. They basically are only loaded once you tell the computer to load them. Then they're usable. So the tidyverse I put here is just because we'll be using it a lot. Basically, it's a whole set of packages or combination of packages that allow us to kind of, go about modifying data as well as graphical and setup of models. So just keep that in mind that basically you can type as much as you want into the computer, something called LM used for OLS models. Unless you load those packages, it does not work yet. You have to load them. Okay. We're also going to be doing functions. Basically, we're going to need to know some of the understanding of how R structures the data. So, just the different class of data in terms of vectors, matrices, and data frames. A lot of times, like I said, Stata and other programs, basically, once you put the data in, whatever the format is, that's what it is. Here, you basically have to go through and put a little more investment in terms of knowing exactly how the data is structured. And then we're also going to look at some tools in terms of loops for these outcomes. One of the most important things here is we're going to do something called pipes. Basically, it's allowing us to combine different functions to basically put multiple operations together to save time. And then basically it's just a way of creating an ordered structure. It helps us in terms of understanding not only our code, but somebody else understanding our code as well. And we do have alternatives to this. It's just that it's become such an essential part of RStudio and R that basically there's not a lot of material out there that sort of goes into those alternatives as much. So they are there. It's just that, like I said, they have really a lot of material out there that helps you in understanding how we structure this stuff. And then we're going to try to integrate all these types of things into some output that then we can basically see. Okay, that includes tables, figures, and more basically with this sort of session. And hopefully it just sort of, one, improves your understanding of this, and hopefully it might improve the workflow of your research itself. Okay? So just before we get to the other stuff, I just want to say I'm going to switch back and forth a little bit from my R to the slides sometimes. In this case, it's mainly to show you exactly how things are set up sometimes. If you have trouble with the background of things, let me know during the break and I can try to adjust the coloring to improve how you can see it if it's not very readable right now, okay? Basically, once you get RStudio running, I'm not going to show you R because, like I said, nobody really uses that interface. Actually, let me sort of be specific. Most time we use this particular interface for RStudio. A lot of times, though, if you use R by itself without, if your program's running, you can speed it up significantly just because, again, R is a base program. But overall, I'm not going to show you that interface just because it is a little bit plain and most people don't like it. So this is going to be most likely what you're sort of seeing in terms of RStudio. There are other IDEs or GUIs out there that basically give you a different sort of setup and they integrate well with it. It's just, this is the one I use. You find the one that works for you. when it comes to how we're seeing this basically is, and well, you can't really see it right now, but basically this would be generally where you would find your coding, usually referred to as an R script. When it comes to the actual console though, whatever you're typing in is going to be on the bottom left unless you change the setup. Output can be here in terms of figures or graphs. And then basically your data frames, or we'll get into that in a little bit, are here. So if you're used to Stata, basically when you open a data set, that is a data frame. Okay. If you want a different data set in there, you have two options. You can get rid of the one that you have, or you can do a frame change. They introduced that recently basically to allow for that overlapping sort of data sets. But that is roughly the same way we have in terms of this, but basically your data frame is, the different ones are listed on this side. Okay, so this is the compact view of RStudio. It's trying to put everything into these frames. You can rearrange this, you can change the background colors and stuff like that, but generally this is what you're going to see. So if we're actually in R and in the console, I can basically ask for help just like you would in Stata. Sorry, I use Stata a lot as well, so that's why I'll kind of refer to it. Most people are familiar with it. But basically this would allow me to bring up the help information, or basically the formatting information for this particular program. In this case, it would be help LM. And in that case, if we were just looking at it from the RStudio, we'd be basically putting it in here, and it comes up in this frame down at the bottom. Okay, yeah. So basically everything that you ask for in terms of help, you're going to find within this frame here. Basically, we can also do a search through to find topics as well. It's not always that you need to know exactly what you're looking for. Sometimes you can basically use keywords that you know of what you're trying to find. Okay, so I don't know, well, I know, but you don't know what the quantile regression is in this particular RStudio or in R. So basically you could just type in quantile to actually do a search for that particular topic, as long as those packages are downloaded. Okay, so there are ways of getting these types of help files. But remember what I said earlier when I said that basically there's a lot of different resources out there in terms of these things here. So basically this is a whole book for R and data science. Basically it goes through some of the stuff that we'll be working through today in terms of visualizations, working data transformations, but this is a whole book that's free, dedicated to R for data science. So that's why, like I said, this is one of the reasons why we want to use this, because the resources are a lot. And the other thing I'll get into a little bit later, there's a big new helper that's sort of in the last 2 or 3 years that have really helped with people that aren't used to coding. We'll get into that a little bit later. So, like I said, these are the internal type helps. Okay, so what we're going to do now, even though some of you, we're going to kind of go over this and we're going to kind of come back to it after the break. Like I said, we need to get you set up on the R and the RStudio first before you can actually practice this stuff. But what I've done is I've sort of done these little chunks to allow us to see some of the stuff that we'll be having to do when we're using these programs. But I figured if we can cover it a little bit now and then head back and then try some of them out once we have everybody set up. So basically, when it comes to setting up your work, basically everything will be contained within, well, it should be in some ways, contained within the script. And basically that is this particular area here. Right now it is a little big because I need it, you to be able to see it. Usually it wouldn't be this big on my screen. But basically, we're going to be putting our entire structure in terms of loaded libraries, anything else that we need at the very beginning, also comments and things like that will go in here, and this will help in terms of your workflow. If you're thinking in terms of Stata, it's basically like a do file for the most part. I have no idea what the equivalent is in eViews. But basically, there's a desired structure to say how we set this sort of up. Typically, we need to go through and remove everything from the space, especially starting with a sort of a fresh or a clear environment. That can be done in a few ways in terms of a command line that we'll practice in a few minutes here once we get everything set up. Or we can also do shortcuts for cleaning this, cleaning out the cache and everything for starting with a fresh, data, a fresh setup. We always need to mark our working directory. The working directory that's on this particular slide is mine. Don't copy that for yours. You need it to go to where your files are at, because that is pointing to everything that you'll be working on that day. If it's trying to look for a data set, if it's trying to look for something, it's going to need it needs this to be able to find those things. Okay? A lot of times we always want to set this up because I've seen a lot of issues to where you finish your work and you can't find where it was actually saving everything. Okay, so it's one of those general setups. We'll kind of go through some of these commands once we get back. And then one of the things that we always need to do is declare the packages we're going to be using for that day. Now, those packages are very particular sometimes to the programs or the methods that you're using. The other problem is, and you'll figure this out very soon once you start going through this, there are a ton of packages for the same method, all using slightly tweaked methods in some way. Okay? That it can be a little bit, concerning in the sense that basically you're using one thing that uses a particular method. It should be doing the same thing, but your answer might be slightly different because of how the method changes between packages. It also means that there's a lot of different ways of doing things. Like I said before, when I said, that I might use a particular method, yours could be completely different for instruction of tables. In these slides alone, I use 5 different versions of table builds. Reason I had to do that is because basically some programs that we're going to be using don't mesh well with certain output for tables or for figures because they're not in the right structure. That's why it gets a little bit annoying sometimes whenever you're trying to do some work and everything's complete and you can't get it to produce what you want because there's an incompatibility. Also with these packages, sometimes their names, the functions they use, actually create overlap between certain other programs. One of the ones that I know is select in the DPLY. I call it Duplar. I'm not sure if that's what it's called, but it's a package that we use. But that select command basically gets confused between 2 different packages. We'll kind of go in why that's the case and how you might be able to get around it, or not how, well, actually how you would get around it. But that does create some issues, like I said. So there's a lot of packages doing a lot of the same things. And sometimes because of that, basically it does cause errors between builds or between running programs, because it's supposed to be doing one thing, but it's confusing the packages. So you have to be careful on which packages you're using as well. So we'll kind of get into that. But in general, this would be sort of the very start of how you're setting up your scripts, your R script. Cleaning out the environments, putting everything in the right directory, or at least pointing in the right direction for your computer, and then also loading those required libraries. So this is why I said this takes a little bit more setup. Most of the time, once you do this in Stata, you open it back up, you're fine. All right. Here, each setup, you have to know exactly what method you'll be using so that those packages are loaded, and then you can basically continue on with your work. Okay? Like I said, we're going to kind of come back to this and practice it, so don't worry if you're not using it yet. So code execution. Once we run a line of code, basically we can go through and just highlight and click run if we want to. In terms of that, the run is over there. And once we click on it, you're going to see that we can execute one line of code if it's highlighted, or multiple. So basically we can run selected lines. Mine's going to look a little bit different than yours because mine's set up as an RMD file right now. We'll kind of go into that, what that is a little later on. It's not a traditional R script. But basically that's why there's a few additional options here. But usually you can basically run line or lines or run all. And then, or you can do a shortcut in terms of Control-Enter for running the line that you've highlighted, or to run the entire script, we can use Control-Shift-Enter. Now, you have to think about this as starting out anyway, before any packages or anything, that basically it's just, in some ways, a calculator starting out. Without the packages, it doesn't really know anything else. So we can go through basic operations. We can ask it to do things like a basic calculator, doing, 8 plus 4 times 5, and basically it'll spit out the output of 28. Or we can basically put parentheses around these, so basically it becomes 68. So 8 plus 4, first operation, then times 5 to make 68. But this is sort of how it is without the packages. That's all it is. You ask it to display hello or math or anything like that, that's all it's going to do. Once we get into packages, we can actually start feeding in through the functions to allow it to do a little bit more than just act as sort of that basic type system. Okay? And then we also have an example of logical. So we can basically ask it, I know again this isn't too big, but you should have the slides by now. Basically, is 8 plus 5 greater than 5 times 2? Basically, you're asking a question, yes or no, that's it. Logical, nothing else. So from that, basically, if it doesn't return true, something's wrong with your program. And then we can also basically ask it the same thing, but reversing to get it to give us the logical thoughts. Okay? So what I'm trying to just point out here is it's basic. Can't do anything. If I give it an equation, it's not going to know to run OLS yet. If I give it and ask it to do something other than, simple mathematical outcomes, it's really not going to change much. There's a few things in there on the base that we can do, but for the most part, when you think about the research or the equations you're running and stuff like that, it's not at that level until the programs are put in or until the packages are loaded. Okay. We're also going to look at assigning objects. So most of the time you have, instead of, gen some variable equal to whatever. We have the same thing here, but basically what we're doing is we have to assign it to a name. Okay? Basically creating in this case, just a defining this object as A is equal to 8 plus 4 times 5. You can see I got lazy and just basically kept doing that over and over, the same math. But we can also assign the second portion to B, or we can also assign it as a matrix. Okay? But as long as we're defining these things, it will then store those as objects, or sometimes I'll say objects or data frames, but basically they're stored within that upper right-hand corner. And then we can also, again, like I said, we can ask for that logical response, and we can actually define those from those logical responses as an object as well to store that outcome. Okay. We also have random number generators that allow us to produce particular outcomes. So a random uniform versus a random normal. And then from that, we can actually create a data frame. And then lapply basically allows me to put it into a format that I can basically produce, probably not considered a quality table, but a table. And then we can also even ask it to do functions that allow us to simulate things. In this case, the second one is basically simulating the roll of a die. I told it, you have an outcome that's basically 1 to 6. I want you to roll it 1 time. And then I asked it in the second, replicate this 10 times. So basically, I just going through and simulating the roll of a die for 10 times here. That allows me to then get the answer from this particular set of numbers. And then we also have a loop. Basically from this, we can basically go through the summation of a continuous value, and then basically print out basically the sum of the numbers from 1 to 10 is, the answer is 55. But you can see how the operations are. This isn't something typically you do in state or eViews in terms of operations, but it becomes a lot more important in these types of things because you are creating these objects as you go through. You're going to be, in some cases, to either save space or time or any of those things, you're going to need to sort of strip out a few variables. You know, subset these things to allow you to create smaller things to when you're running your programs. A lot of times this is helpful just for computers in general. Because one thing I haven't mentioned so far, these objects, everything that you're creating is stored within the RAM, not within the hard drive. That ends up becoming a little bit of an issue, especially whenever you get into the big data type world. The more stuff you're storing there, the harder it is for your computer to sort of go through and to do those programs because you're eating into other space. It also doesn't help that most people keep like 20 windows open in Chrome or whatever they're using, which also eats up RAM. Okay, so those are things that basically, these things seem simple at the very beginning, but basically they can simplify the life in terms of keeping only what you need, generating those things, and then throwing away the rest to basically keep everything as compact as possible when you're running these programs. Okay. We also have matrix operations. It basically allows us to go through, and this would be sort of the MATLAB side of it, that basically you can do these things. You also have this in state as well under something called meta, if you're used to using that. But basically we can go through with matrix operations to allow us to create a matrix, do a simple transpose, multiply matrices together, and then also ask for determinants, eigenvalues, all those things are available to us. Okay? And then we have types of data. Now, sometimes this gets a little tricky because basically you might think a particular data is, numerical, but it could be already factored out. So yes, no, however you're making the binary or categorical variable. Sometimes you have to make changes from the way it looks from, you know, a number to a character to a logical, sorry, integer, and then factorial, and then complex. A lot of times, like I said, you don't deal with these in other programs because most time, if I know I keep going back to Stata, but basically, typically you have numerical, string, or you have an encoded variable, and most people don't go beyond that. So those are basically sort of the three that you generally deal with. Here, you have to know exactly what class you're actually dealing with because certain programs will only accept a particular class. Okay, so we're not going to see this today, but just to give you an idea, at a later stage in day 4, I was using programs that didn't like the fact that I had one as yes, no. I actually had to turn it to numerical before I could use it for a program. But for a program that's supposed to be doing the exact same thing, yeah, or a similar function anyway, it didn't care. It accepted the yes, no. So that's the thing. So you sometimes have to adjust how the data actually looks to be able to get what you want. Okay. So I know this is a little bit early on the break, but the reason I was kind of going through this is because what we're going to try to do now, we're actually not going to break. We're going to kind of set you up on the R if you haven't done it yet. And what I want you to do is sort of go through and actually practice these particular codes if you have the slides already.